Hello friends and welcome to Notebook. All of you have played carom sometime, right? Today we will see a new type of carom game being played and maybe even learn something interesting from it. Let's have a look. Firstly, there are no different colored pieces. What we have are identical white pieces with a number written on top. The number of pieces captured indicates the points scored. A player has to score maximum points in a given time interval. If a player manages to pocket the pieces of sets N, W, Z or Q, they get bonus points. Our player begins. Within a few moves, he has pocketed the pieces 1, 2, 3 and so on. The scorer gives him the total points as well as a bonus, as he has captured all pieces of set N. Next, he pockets 0 and the scorer gives him another bonus, as he has got all pieces of set W. Now he starts capturing pieces -1, -2, -3 and all other negative numbers. When none are left, the scorer gives him another bonus, as he has captured all the pieces of set Z. Finally, he pockets the remaining pieces 1 by 2, 1 by 3, 2 by 5, 8 by 3 that have fractional values. The scorer gives him a bonus for capturing all pieces of set Q. Friends, do you know that this game of carom that we just saw is very similar to the different kind of numbers that form part of our number system? Let us see how. We said that 1. The first set contains numbers starting from 1, 2, 3, etc. and is marked as N. These numbers starting from 1 are actually natural numbers, N. Therefore, we can define natural numbers as natural numbers, N. The counting numbers are called natural numbers. It starts with 1 and ends at infinity. N is equal to 1, 2, 3, 4, 5 and so on. Moving on to the next set now, 2. The second set contains numbers like 1, 2, 3, etc. including 0. This row is marked as W. These numbers starting from 0 are actually whole numbers W. Therefore, we can define whole numbers as whole numbers W. When 0 is included in the set of the natural numbers, it is called a whole number. W is equal to 0, 1, 2, 3, 4, 5, 6 and so on. Alright friends, moving on. 3. The third set contains negative numbers like -3, -66, -40, etc. and is marked as Z. These numbers are actually integers, Z. Therefore, we can define integers. Integers Z, the whole numbers along with negative natural numbers make up the integers. Z is equal to -4, -3, -2, -1, 0, 1, 2, 3, 4 and so on. Now, last but not the least friends, fourth set. 4. The fourth set contains numbers like 1 by 2, 1 by 3, 2 by 5, etc. and has many such numbers. This row is marked as Q. These numbers are actually called rational numbers, Q. Therefore, we can define rational numbers as rational number Q, a number that can be expressed in the form of P by Q, where P and Q are both integers and Q is not equal to 0. Friends, did you know that rational numbers include whole numbers, natural numbers and add integers. Can you tell me how? Yes, right. This is because all these numbers can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. For example, minus 15 can be written as minus 15 by 1. Here, P is equal to minus 15 and Q is equal to 1. Rational numbers do not have a unique representation in the form P by Q. For example, 1 by 2 is equal to 4 by 8, is equal to 8 by 16, is equal to 10 by 20, and so on. These are equivalent rational numbers or fractions. So friends, after refreshing our knowledge on these different types of numbers, today we will learn about some properties of rational numbers. Remember friends, we have already learned in earlier classes about the properties like closure, commutative, associative and distributive. Now, we shall check these properties for rational numbers in relation to the different kind of mathematical operations. So let us start. Properties of rational numbers. Friends, in our lesson today, we shall look into the various properties, that is, closure, commutative, associative and distributive, in relation to all the mathematical operations for all the different numbers, that is, natural numbers, whole numbers, integers and rational numbers. Sounds good? So let us start with closure property first. At each step, we shall use small examples to make our concepts clear. Here we go. Closure property. 1. Natural numbers. We shall now check which of the operations under natural numbers satisfies the closure property. A. Addition. What happens if we add any two natural numbers? For example, 2 plus 3 is equal to 5. So we see that the answer, in this case 5, is also a natural number. Thus we can say that natural numbers are closed under addition. Next, B. Subtraction. What happens if we subtract any two natural numbers? For example, 2 minus 3 is equal to minus 1. So we see that the answer, in this case, minus 1, is not a natural number. Thus, we can say that natural numbers are not closed under subtraction. Next, C. Multiplication. What happens if we multiply any two natural numbers? For example, 2 multiplied into 3 is equal to 6. So we see that the answer, in this case 6, is also a natural number. Thus, we can say that natural numbers are closed under multiplication. Next, D. Division. What happens if we divide any two natural numbers? For example, 2 divided by 3 is equal to 2 by 3. So we see that the answer, in this case, is not a natural number. Thus, we can say that natural numbers are not closed under division. Let us now move to whole numbers. 2. Whole numbers. We shall now check which of the operations under whole numbers satisfies the closure property. A. Addition. What happens if we add any two whole numbers? For example, 0 plus 3 is equal to 3. So we see that the answer, in this case 3, is also a whole number. Thus, we can say that whole numbers are closed under addition. Next, B. Subtraction. What happens if we subtract any two whole numbers? For example, 0 minus 3 is equal to minus 3. So we see that the answer, in this case, minus 3, is not a whole number. Thus, we can say that whole numbers are not closed under subtraction. Next, C. Multiplication. What happens if we multiply any two whole numbers? For example, 0 multiplied into 3 is equal to 0. So we see that the answer, in this case 0, is also a whole number. Thus, we can say that whole numbers are closed under multiplication. Next, D. Division. What happens if we divide any two whole numbers? For example, 2 divided by 3 is equal to 2 by 3. So we see that the answer in this case is not a whole number. Thus, we can say that whole numbers are not closed under division. Is it clear till this part, friends? With this, friends, we come to the end of our video lesson. You can repeat this video again and again until all your doubts get cleared. See you soon again. Till then, goodbye.